Hi, my name is Robert Ayton, and this is EDCI 557, the Technology-Based Science Classroom, and we're going to take a virtual field trip today. A virtual field trip out your front door and into our solar system. All right, and our beautiful solar system has at its center, the center of our neighborhood, the sun. Okay, the center star. And this star has all the planets revolving around it. It is so wide that it could hold 109 planet Earths across its surface. And if it were a hollow ball, you could fit more than 1 million planet Earths inside of it. It's made up of hot gases that account for more than 99.8% of the total mass in the solar system. And these gases are at about 10,000 degrees Fahrenheit at its surface and more than 28 million degrees Fahrenheit at its core. And deep in the sun's core, what happens is we have nuclear fusion reactions that convert hydrogen gas to helium gas, which then creates energy, which then travels throughout the entire solar system in the form of light photons. Earth's gravity is 28 times that of Earth. And we're going to take a relative approach to taking a look at how big the sun is compared to all the other planets. The sun, if you view it as a basketball, okay, we're going to take a look at how those other planets are compared to a basketball. And if you compare the sun, if you think of the sun at being the center of New York City, if we only walk about a third of a block away, only about 100 feet away, we get to Mercury. Okay, and Mercury is our closest planet. It's about the size of a marble compared to that basketball. Mercury's elliptical orbit takes it as close as 29 million miles towards the sun and as far away as 43 million miles away from the sun, which means the sun, if you were standing on the surface of Mercury, the sun would appear almost 3 times larger than it does on the surface here on Earth. And which means temperatures can reach really high temperatures up to about 800 degrees Fahrenheit, but because there's no atmosphere to retain that heat, nighttime temperatures can drop to negative 280 degrees Fahrenheit. You can see it looks very similar to our moon, doesn't it? And because it's been scarred by so many impact craters resulting from collisions from meteoroids and comets. And although it's the second smallest planet in our solar system, it's the second densest because it has a large iron core to it. Now, if you go from the center of New York City and you walk out about 2/3 of a block, okay, about 200 feet away, you would hit Venus, okay, the morning star. And Venus is about the size of a pebble compared to that basketball of the sun. And Venus and Earth, you can see the picture up in the upper right-hand corner, they're similar in size, mass, density, composition, distance from the sun. However, Venus is covered by a thick, rapidly spinning atmosphere, which creates a scorched world with temperatures hot enough to melt lead and a surface pressure 90 times that of Earth. Its clouds reflect almost all the sunlight, which means that it looks almost like a star up in the sky. Okay? And its atmosphere consists mainly of carbon dioxide with some sulfuric acid droplets, and that atmosphere traps heat inside, which creates about 860 degrees Fahrenheit. Okay, probes that have landed on Venus have not even survived more than a few hours because it's destroyed by the heat. Now, what's amazing is the day of Venus is actually longer than its year. Okay, because it's rotating so slowly on its axis, it actually rotates retrograde, which means east to west, compared to Earth's prograde, which is west to east. And it's going so slow, but the atmosphere has this super rotation which creates hurricane force winds that are still being investigated today. And if we go from the center of our universe and we go out just a little bit more, we hit the third rock from our sun. Earth is about the size of a pebble compared to the sun, a basketball. And it's about a block away if you go to New York City relationship there. And this big blue marble, it's the only planet known to support life. Okay, it's the third planet from the sun. It's the 5th largest in our solar system. And we know the 4 seasons are a result of its 23-degree axis of rotation, the tilt of that axis. Our oceans are more than 2.5 miles deep, and it covers nearly 70% of our Earth's surface. And we know our atmosphere is about 78% nitrogen gas and 21% oxygen gas, the perfect mixture for us to be alive. And that mixture affects the long-term climate, the short-term local weather, and it actually shields us from ultraviolet radiation, protects us from meteors. Okay, an amazing, amazing planet Earth. Now, if we just go a little bit more away, we hit Mars. Okay, and Mars is we know it as the red planet. Okay, it's a little bit smaller than Earth, and it has some similar properties to Earth, but its plate tectonics are different. Our plate tectonics on Earth slide horizontally, and in order to spread apart the sea floors. But the tectonics in Mars seem to be vertical, with hot lava pushing them upwards through the crust to the surface. And periodically there's great dust storms that engulf the entire planet, and the effects of these storms are dramatic. It has actually one of the largest volcanic mountains in the solar system, and it has a canyon system that stretches the equivalent distance of New York to Los Angeles. It also has 2 small moons, but it's not too far away from the sun. But if you think about Earth is about 1 block away in our analogy of New York City. If we go 5 blocks away, so 5 times the distance of Earth, we hit Jupiter. And Jupiter is about the size of a baseball compared to that basketball. It's huge. It's the largest and most massive planet in our solar system. It's got 4 planet-sized moons and 45 smaller moons. And it's so massive it forms a miniature solar system in and of itself. If it had been 80 times more massive, it would have been a star rather than a planet. And Galileo Galilei, the astronomer, on January 7, 1610, he used a primitive telescope and he discovered the 4 moons of Jupiter. And Jupiter's appearance is a tapestry of beautiful colors and atmospheric features. Its clouds are composed mostly of ammonia. And you can see these strips of these dark and light zones, and they're created by strong east to west winds in the upper atmosphere. You can see the giant red spot down in the lower right-hand corner, and that's a spinning storm that has been observed for more than 300 years. Its atmosphere is similar to the sun, composed of mostly hydrogen gas and helium gas. Now remember, that was 5 times the distance, 5 blocks away, almost 5 blocks away from the sun compared to the 1 block of Earth. Now we would have to go almost double that distance, double Jupiter, which is about 10 blocks away, or half a mile away from that center of New York City, to the size of a cue ball, which is called Saturn. In 1610, Galileo Galilei was the first to gaze through a telescope to see Saturn, and to his surprise, he saw a pair of objects on either side of the planet, and he concluded that Saturn had to be triple-bodied. Okay, but in 1659, Christopher Huygens used a more powerful telescope and proposed that Saturn was surrounded by a thin, flat ring. And Cassini discovered that there was a division between these rings, which they now call A and B rings, and it's now called the Cassini division. Saturn is made up of mostly hydrogen and helium, and its volume is 775 times greater than that of Earth. Winds in the upper atmosphere can reach 160 feet per second, which is 4 times greater than Earth's top hurricane force winds. And these super fast winds, combined with the heat from its interior, causes yellow and gold bands visible in the atmosphere. You can see Saturn's most distinct feature: its rings. Its rings are an extensive and complex system, extending hundreds of thousand kilometers from the planet. And we even know two of Saturn's moons are in the gaps of those main rings. And it has 52 known moons, and its largest is called Titan. And so that is about 10 times the distance of Earth out. And that we come to Uranus, which is the blue planet. And Uranus it was discovered by William Herschel in 1781, and its distance is so far. You can see it is double the distance of the Sun to Saturn. It's about 20 times away. It's the size of a peach cord compared to that basketball. It's so far away it takes 84 years to complete just one full orbit. It's one of the brightest clouds in the solar system. We call it the blue planet, and it has 11 rings. And it's not a solid surface. It's one of the gas planets, and it's composed of mostly hydrogen gas and helium gas, with a little bit of methane gas mixed in there. And this planet is a blue-green color that comes from the methane gas. The sunlight gets absorbed by the methane gas, and that red wavelength of light gets absorbed, and what we see is the blue wavelength. And what's crazy is its rotation is nearly horizontal, like it's been knocked on its side, which means that it experiences seasons that last over 20 years. That's a long winter. And it has over 27 known moons. And so if we go out from this planet Uranus out to the furthest planet from the sun, Neptune, the outermost planet, that would be over, if you're staying in the middle of New York City, about 1.5 miles away. 1.5 miles away, about 30 blocks away. And Neptune is the first planet to be located through mathematical predictions rather than through regular observations in the sky. It's nearly 2.8 billion miles from the sun, which means it orbits the sun once every 165 years. It's naked to the human eye because it's extreme distance from the Earth, and its main axis of its magnetic field is tipped over about 47 degrees, which creates just wild variations and a magnetic field 27 times more powerful than that of Earth. Again, its blue color, this rich blue color, comes from its methane gas. It actually has 6 known rings and 13 known moons. And friends, that is our solar system. If you want any extra information on the solar system, go to NASA, go to National Geographic. They have absolutely great resources for you to learn more about the solar system. And if you want to view this presentation again, just click on this hyperlink and you will be right there. Thank you for viewing this virtual field trip of our beautiful solar system.